Hello everyone, welcome to my channel Strong Math. Today I'll start a new section in the series of video lectures of my channel. In this series of videos, I will give lectures on mathematics of class 8. Today we'll discuss about the first chapter, which is rational number. In today's lecture, you will understand about the closure property of different numbers. So watch the video very carefully and try to understand each and every word. At first, let us recall the numbers. If you have not watched my video of beginners algebra, you can watch that video to understand different kind of numbers. So let's start natural numbers. What are natural numbers? Natural numbers are 1, 2, 3, 4, etc. These numbers are God gifted numbers and these numbers are used for counting, right? Now what are whole numbers? Whole numbers are the natural numbers including the 0. That is, whole numbers are 0, 1, 2, 3, 4, etc. What are integers? Integers can be written as -3, -2, -1, 0, 1, 2, 3, etc. All the numbers are infinite numbers. What are rational numbers? Remember, in class 7, you have learned about rational numbers. For example, 1 by 2, 3 by 4, -1 by 3, -1 by 5, etc. These are rational numbers. Let's recall the definition of rational numbers. A number which can be expressed in the form of p by q, where p and q are prime to each other and they are integers. Prime to each other means their HCF is 1 in the lowest form, right? And q not equals to 0 is called a rational number. This is the definition of rational number. You may note down the definition of rational number. Okay. In the previous class, that is in class 6, class 7, you have already learnt about the number system. Now in class 8, you will learn in this chapter about the properties of rational numbers. Okay. With respect to some operations. What are the operations? Addition, subtraction, multiplication and division. The properties are: number 1, closure property, number 2, commutative property, number 3, associative property, number 4, identity property, number 5, inverse property, and number 6, distributive property. We will discuss each and every property one by one. In today's lecture, we will discuss only the first property, which is closure property for every numbers. To understand this property, at first look. Suppose we are taking two numbers 2 and 5. Okay. You may say that 2 and 5 are natural numbers, 2 and 5 are integers also, right? Now let's add them. 2 plus 5 gives us 7. Now if we think 2 and 5 as natural numbers and their addition gives us 7, which is also a natural number. If this happens for any kind of operations like addition, subtraction, multiplication, division, and for the same elements, same set of elements, that means here we took natural numbers and get a result which is also a natural number. Okay, then we say that the numbers are closed under that operation. Let's explain. So the closure property, here I explain that one. If we take a particular operation, that is addition, subtraction, multiplication or division, say addition. Here we choose the operation addition. And if we consider a set of particular numbers, say all the natural numbers, here we collect all the natural numbers. Okay, that is the numbers are 1, 2, 3, dot 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 up to infinity. Now if we do the operation, which operation? Here addition, in between any two numbers of that particular set. Here we choose the set of all natural numbers, and if the resulting number is also a number of that set, that is, if the resulting number is also natural number, then we say that under the operation, here the operation is addition, the set, here the set is of all natural numbers is closed. Okay. If we take a particular operation, say addition, the symbol of addition is plus, and if we consider a set of particular numbers, say all the natural number, and the natural numbers are 1, 2, 3 up to infinity, and if we take any two numbers, say 2 and 3, and do the operation, now add, if the resulting number, here 2 plus 3 is 5, the resulting number is 5, belongs to that set. We know that 5 is also a natural number, right? So 5 belongs to this set. So if the resulting number belongs to this set, then the numbers are called closed under addition. Clear? This is the closure property. So for example, for addition, we can take for natural numbers 2 and 5. Now if we add them, 2 plus 5 gives us 7, which is also a natural number, right? Again, if we choose 2 and 1, then if we add them, 2 plus 1 is 3. This is also a natural number. This is also a natural number. So we conclude that natural numbers are closed under addition. For whole numbers are 0, 1, 2, 3, 4, etc. So if we choose 0 and 1 and add them, 0 plus 1 is equals to 1. Look, 1 is present here. Again, if we choose 2 and 3 and add them, 2 plus 3 is equals to 5, which also belongs here. Therefore, we say that whole numbers are also closed under addition. Similarly, you can check for integers as well as rational numbers. For integers, suppose if we take two integers minus 2 and 3 and add them, minus 2 plus 3 is equals to 1, which is also an integer, right? Again, if we choose 0 and minus 3 and add them, 0 plus minus 3 is equals to minus 3. Minus 3 also is an integer. So we can say that all the integers are also closed under addition. Now you can check for the rational numbers also. Take any two rational numbers and add them. If you get rational numbers, then you can say that rational numbers are also closed under addition. Now check it. Now we are going to check the closure property for subtraction. We use the symbol minus for the operation subtraction, right? For whole numbers, that is 0, 1, 2, 3 up to infinity. If we do the operation subtraction for any two whole numbers, say 0 and 1. Now if we do this operation, that is if we subtract 1 from 0, then 0 minus 1 gives us minus 1. Look very carefully. Is minus 1 a whole number? No. Again, suppose if we assume 3 and 2 and let's subtract 2 from 3, then 3 minus 2 is 1. Is 1 a whole number? Yes. Remember one thing, to hold a property, the property should be satisfied for all the numbers. Look, for 3 and 2 we get the whole number 1, but for 0 and 1 we get minus 1, which is not whole number, right? So we say that closure property does not hold for whole numbers under subtraction. Clear? Now for integers. What are integers? Minus 2, minus 3, 1, 0, minus 1, 7, etc. are integers. Now if we take any two integers, suppose minus 2 and 7. Now do the operation subtraction. Minus 2 minus 7 gives us minus 9. which is also an integer, right? This is also an integer. Again, if we choose 1 and 2 and subtract them, 1 minus 2 gives us minus 1, which is also an integer, right? So here we say that for integers under the subtraction, integers are closed. So closure property holds for integers under subtraction. Now for rational numbers. Rational numbers, say 2 by 7, 1 by 2, 2, 0, all are rational numbers. Now if we subtract them, suppose 2 by 7 minus 1 by 2, then the result will be minus 3 by 14. Is minus 3 by 14 a rational number? Yes. Now if we choose 2 and minus 1, both are rational numbers. Remember the definition of rational numbers. 2 and minus 1 are also rational numbers, okay? Now if we subtract them, 2 minus minus 1 gives us 2 plus 1, which is 3. Is 3 a rational number? Yes, 3 is also a rational number. So for rational numbers are closed under subtraction. Clear? Now if we choose natural numbers are 1, 2, 3, 4, etc. and the operation is subtraction. Now if we subtract any two natural numbers, say 1 and 4, then 1 minus 4 is equals to minus 3. Is minus 3 a natural number? No. If we choose 3 and 5 and subtract them, 3 minus 5 is equals to minus 2. Is minus 2 a natural number? No. But look, if we choose 5 and 2, then 5 minus 2 is equals to 3. 3 is a natural number, right? But we know that to hold a property, the property must be satisfied for all the numbers. Here minus 3 is not natural number, minus 2 is not natural number. So natural numbers are not closed under subtraction. Now it will be easy for you to understand the closure property about multiplication and division. For whole numbers 0, 1, 2, 3, 4, etc. if we choose 0 and 1 and multiply them, then we will get 0, which belongs to the whole numbers. If we choose 2 and 3 and multiply them, then this will give us 6, which is also a whole number. So whole numbers are closed under multiplication, right? For integers are negative integers, 0, 1, 2, that is positive integers, all are integers. If we choose minus 3 and minus 2 and multiply them, then this will give us plus 6, which is also an integer. If we choose 0 and minus 3, then this will give us 0, which is also an integer. So for integers are closed under multiplication, right? For rational numbers, suppose 1 by 4 and 2 by 7. If we multiply them, then we will get 2 to the 4, 1 by 14, which is also a rational number. If we choose minus 1 by 3 and multiply with minus 2 by 3, then this will give us minus plus 2 by 9, which is also a rational number. So rational numbers are also closed under multiplication. Similarly, if we choose natural numbers, that is 1, 2, 3 up to infinity, then if we multiply them, then 1 into 2 gives us 2, which is also a natural number. 3 into 4 is equals to 12, which is also a natural number. So natural numbers are also closed under multiplication. Now we will check the closure property for the operation division. Okay, look very carefully. The whole numbers 0, 1, 2, 3 up to infinity. If we divide 1 by 2, then we will get 1 by 2. Look, half is not a whole number, right? So whole numbers are not closed under the division. Similarly, you can check, if you divide 2 by 0, 2 divide 0 is undefined. This is not possible. Okay. Similarly, if we choose integers, 0 is an integer also. If we divide something, suppose 12 by 0, which is also undefined, and hence we can say that integers are also not closed under division. Clear? Without 0, you may check, if we divide 4 by 6, then this will gives us 4 by 6, which is 2 by 3. 2 by 3, now look, 2 by 3 is not an integer, this is a fraction. So integers are also not closed under division. Clear? For rational numbers, suppose 1 by 4 divides 2 by 4, then this will gives us 1 by 4 into 4 by 2, which is half. So half is also a rational number. Okay, but we know that 1, 2, 0, these are also rational numbers. So if we divide 1 by 4 by 0, this will gives us undefined term. So rational numbers are also not closed under division. Now it will be easy for you to understand the closure property about multiplication and division. For whole numbers 0, 1, 2, 3, 4, etc., if we choose 0 and 1 and multiply them, then we will get 0, which belongs. Therefore, natural numbers are also not closed under division. Right? Let us form a table. So we have natural numbers are closed under addition. Yes. Are natural numbers closed under subtraction? No. Are natural numbers closed under multiplication? Yes. Natural numbers are not closed under division. So no. Whole numbers are closed under addition? Yes. Whole numbers are closed under subtraction? No. Under multiplication? Yes. Under division? No. Integers are closed under addition? Yes. Under subtraction? Yes. Under multiplication? Yes. Under division? No. Rational number under addition are closed? Yes. Rational number under subtraction are closed? Yes. Are rational numbers closed under multiplication? Yes. But not closed under division, so no. In the next video, we will discuss about the other properties like commutative property, associative identity, inverse and distributive property. If there is any kind of doubt or query in today's lecture, please do comment below. Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel Strong Math. Mention your query. Keep watching. Thank you.